This is section 3.4 day 2, and now we're going to switch into log solving. So the first lesson was all about exponents, and now we're going to switch over to logs. Sometimes we end up in exponentials even when we are solving a log, because sometimes that's easier. But all the problems we're going to do today are going to start in log form. So this first one has a log of base 5, and the base is not important. Remember, the algebra that we're going to do is what's important. I'm going to quick throw a parenthesis around this. That should be a quantity that we're taking the log of. And so if you could kind of see this almost like when we did the exponents where we kind of covered it up, this is one big group that can't be split up right now. So I'm going to start off by dividing by 2. So now I have log 5 of 3x equals, and 4 divided by 2 is just 2. I don't really know how to attack a log 5 of 3 to the x. I can't separate these two, but I could switch to exponential, so that's what I'm going to do. 5 squared equals 3x, and 5 squared is 25 equals 3x, and if I just divide both sides by 3, whoops, I get about 8.3. So in this case we took our log, got it as isolated as we could, it was by itself, and then we switched to exponential to finish the problem. The next one, I have 2 logs, and now these 2 logs are being separated by addition. So don't forget, too long ago you were doing like log u plus log v, and we just turned that into multiplication. So I'm going to do the same thing here. I'm going to have log 3 and then x and x minus 8 equals 2. So kind of just smushing these 2 logs. I'm condensing these 2 logs together into one. Here I have just a single log with a quantity. It's isolated. There's nothing else on this side with it. So this is my opportunity to switch to exponential. And now I just have an algebra problem. So I've got 9 equals x squared minus 8x. We're going to move the 9 over. And then you have a couple of options. You can do the quadratic formula. You guys all have a program. You could factor. Factoring for me is just a little faster. But you could enter this in your program and you'd get the same answers. So x minus 9x plus 1, that means that in the end my answers are 9 and negative 1. When you are doing these, if you kind of saw in your notes, it says we do have to check our answers. So if I were to take a 9 and plug it in here, I could find the log of 9. And 9 minus 8 would be 1. I could do the log of 1. Negative 1, though, I cannot do the log of a negative. We talked in the previous lesson about how I cannot find the log of any negative number. Logs don't exist on the negative side, so this one won't work at all. So just make sure that you go back and check that what you're plugging in is going to make sense. So just to show you completely, I've got log 3, 9, plus log 3, and 9 minus 8 is just a 1, equals 2. The log of any base of a 1 is just 0, so that's not there. Log 3, 9 equals 2, and then I could switch to exponentials, and 3 squared equals 9. Yep, it does. So just checking that the 9 works. The next problem we have has 2 logs, but these ones are being subtracted, and subtraction turns into division. And there isn't a base here, but if you remember, if there is no base on a log, that it is base 10. So I'm just going to squeeze that in there. And then we are at a place where my log is isolated. There's nothing else on this side with it, nothing else I can do. So I'm going to switch to exponentials. All right, now we've just got an algebra problem. I'm going to throw the 10 over a 1, even though we don't usually write that, but it's going to help me just cross multiply to solve this proportion. So I'm going to have x times 1, and then I'm going to have 10 times x minus 3. Do a little distributing, 10x minus 30. Subtract the 10x over, and then just divide by negative 9. So I've got negative 30, whoops, divided by negative 9. So 3.3 repeating. Check your answer just to make sure that it will work. Log of 3.3, I can totally do that. And then 3.3 minus a 3 will just be 0.3, and we can log that as well. Couple more to go. So this one's got 2 logs, but they are separated by the equal sign. And anytime those log bases match each other, so log 3, we've done one like this before, but you didn't have like a quantity, you just had a single letter. So this 5x minus 1 has to equal the x plus 7. So if the logs are going to be the same, then the things we're taking the log of also have to be equal. So that'll be 4x and an 8, and then I will get 2. Here I've got two logs again. They happen to be natural logs, but they're logs just the same, and they're being separated by addition. So I'm going to smush them together. I'm going to condense them together with multiplication. And then I do have natural logs on both sides. That's an interesting situation. And then I've got two sets of parentheses there that look like eventually I might have to FOIL this and kind of FOIL that out. Sorry, excuse me, I'm losing my breath here. So natural log, I've got 1 on each side. This 2 can go back as a squared. And if I've got natural log of all of this stuff and it has to equal natural log of this stuff, that means the stuffs have to be equal. Kind of like what we did on the last one. We had similar logs, or we had the same log on both sides, log base 3. Here we have log base e on both sides, which means that the quantity, the thing we're logging, they have to be equal. So I'm going to distribute. I'm going to get 2x cubed minus 3x minus 4x plus 6, just FOILing that out. I'm going to minus this x squared over. Well, that's a squared, not a cubed. So then I just wrote 2. So if I subtract that x squared over there, I'll just have an x squared. These two will be negative 7x, and then I've got the plus 6. So I can quadratic formula at this point, or I could factor. Factoring for me is just a little bit quicker because I've been factoring a very long time. This will be a minus 6 and a minus 1, so my two x's will be 6 and 1. Remember, we're just going to check those again. So 6 minus 2 would be 4, and 6 times 2 would be 12 minus 9, so I could calculate the logs of both of those, and log of 6, that would work as well. Even ones, the log of 1 is 0, but here I put a log 1 in, or I'm sorry, I put a 1 in. 2 times 2 is 1 minus 3, that's actually a negative 1, and I cannot do the log of a negative. Here's the same problem. 1 minus 2 would be negative 1, and I can't do the natural log of a negative. So I'm going to take out that value. One more to go. We've got natural log square root of x plus 2, and then you've got a natural log of x on the other side. And I'm just going to change the root into an exponent. So it's going to be to the 1/2, and then I've got natural log of x. Kind of in the same boat again, I've got natural logs on both sides, so that means that these two parts are equal. So x plus 2 to the 1/2 equals x. The only way really for me to get rid of a 1/2 or to get rid of a root is to square it. So they'll cancel, and I'll throw a squared over there. So I've got x plus 2 equals x squared. Moving everything over, so it's all on one side. And then we're up to our quadratic formula, or we are factoring again. So it looks like my two answers are 2 and negative 1. This is where we got to check. So 2 plus 2 is 4. I can square root 4, I'd get 2. That would equal the natural log of 2, so we're good. Plugging in a negative 1 is where we get in trouble. Negative 1 plus 2 is a 1, so I could do square root of 1. But over here I'd have natural log of negative 1, which I cannot do. So it doesn't really matter if it's a negative or a positive. You need to plug it back in and check that it will actually work. And you're just looking to see if when you plug it in, if you're making negative things that you're trying to log, that's what you have to cross off, because those can't happen.